Hi, this is Andrea Hendricks. The object of this video is to show you how to graph the inverse tangent function, and we're going to look at the domain and range of that and evaluate the function as well. Well, I've drawn for you here the graph of the tangent function. Remember, tangent is one of those weird ones that has asymptotes everywhere that cosine is 0. And we see that it has zeros everywhere, sine is 0. So hopefully you have this function, again, somewhat committed to memory in the way that the graph looks. But we find another problem, that it is not one-to-one. So we have to do the same thing that we've done with sine and cosine, and that is restrict the domain on an interval that has all of the range values covered. Now remember that the domain is everything minus pi over 2 plus n pi, and the range for tangent is from negative infinity to infinity. So we want to restrict it so that we have a piece of the graph that covers from negative infinity to infinity, and the way that we do that is we restrict it between these first two asymptotes that include the 0 value. So the restriction of the domain of tangent is going to be from negative pi over 2, remember I cannot include those because there are asymptotes there, to pi over 2. And my range is from negative infinity to infinity. So when I do the inverse function, tan inverse or arctan of x, what's going to happen? Well, in this case, my domain now is going to be all reals from negative infinity to infinity, and my range is going to be from negative pi over 2 to pi over 2. And notice that I'm going to have asymptotes, because wherever I have vertical asymptotes, the inverse function will have horizontal asymptotes. And again, the graph is a reflection across the line y equals x, so if we reflect it, we're going to get this shape. So again, whenever we're asking ourselves to think about what does y equals tan inverse of x mean, well, that is true if and only if, we can use an abbreviation for that, IFF, if and only if tangent of y is equal to x. Well, again, that's asking ourselves to figure out what angle has a tangent of x. Well, what does our angle have to be? Well, our angle has to be between negative pi over 2 and pi over 2. Okay. So this one's going to be a little bit different in the sense that our domain is all reals. Okay, we're going to put in anything because the tangent values are all reals, but the output is going to be the angle between negative pi over 2 to pi over 2 that has that tangent value that is input. So if I want to evaluate arc tan of 0, there I'm trying to think about what angle between negative pi over 2 and pi over 2 has a tangent value of 0. And remember, tangent is sine over cosine, so this would be where really sine is 0, and that is at 0. And maybe for arctangent and tan inverse you want to use your calculator. These are a little bit more difficult to think about in the straightforward way unless you have those set problems that are actually already given to you. And if maybe on your unit circle you've already found out what the tangent of those angles are by dividing the sine and cosine. What about arctangent? What would that be? Arctangent of negative 1. So that's telling me I need to think about an angle between negative pi over 2 and pi over 2 whose tangent is negative 1. Well, and you can actually look on the graph to see that that is at negative pi over 4. Okay. Now if you wanted to do one more, we could. What about the arctangent or tan inverse of square root of 3? What would that one be? So we're looking at where sine over cosine is the square root of 3, what angle has that? And that is going to be at pi over 3 or 60 degrees. Okay. Now using your calculator, again to input tan inverse we're going to have to do second and then the tangent of x key. And I have set my window for x values between -10 and 10 because the domain of tan inverse is negative infinity to infinity. The range is from -pi over 2 to pi over 2, so I set my y min to be at -pi and my y max to be at pi. And my y scale is at pi over 4. Okay. But so you have to think about the fact that these are really asymptotes, horizontal asymptotes. Okay. And you can play around with inputting these. Tan inverse of -50 is -1.55. Tan inverse of 1 is 0.7853. Continuing on. So that shows you here our domain can really be anything with that example of -50 I put in there. Now remember what the range is. Those are angles in radians. Okay, so if you have any questions on the inverse tangent function, you know what to do. Thanks.